Tutor Polly here, back with another question, volumes of revolution, the washer method. We are taking the curve y equals x plus 1, the x-axis, which is y equals 0, and the bounds x equals 0 and 1, and we are revolving it not about the x-axis, but about the line y equals -1. So this is a little bit of a level 2 problem. First thing you got to do is draw and graph it. So there's our curve y equals x plus 1. There's our axis of revolution y equals -1. There are our x bounds, x equals 0 and x equals 1. And there's the region that we are revolving. So taking from a 2D area there and then taking it, revolving it around and creating a 3D shape and getting a volume. So it's going to see if you can imagine it. Okay, we're taking this y equals x plus 1, the black curve, and going all the way around. Okay, and then we are taking away that part there in the blue curve radius. So first we have to understand what we're even doing. So the generic equation for volume is area of the base times the height, where area is a 2D shape, right? Well, we have circles there, if you see them in the bottom left corner. So we're doing an area of a circle, pi r squared times the height. So very similar to the volume of a cylinder. The thing here is our circles are kind of on their side, and then we are stacking our circles on top of one another, going from a 2D shape, a circle, into a 3D shape, okay, a volume. So here's our equation now, and we can factor out, or we can bring out the pi because the pi is just a constant, and so it's the integral of pi r squared dx, where in this case, the h is the integral and the dx. We are repeating this over and over again. We have one circle there in the bottom left, and then we take another circle, and then we do it again, and then we do it again, and we take all those circles, and now we have a 3D shape. Okay, so that's the integral dx. Well, what is our radius then? What is the radius of this circle? Well, that's our function or series of functions depending on how complicated our graph is. Okay, so in this case, we have to figure out what the r is. Well, we're going to have a big R there, take away a small r there, and then we will be left with our shape in between. The equation will work itself out. So what is our big R? Well, it's going to be that small part there between y equals -1 and the x-axis. So that's 1, okay? And then it's going to be from the x-axis to our black curve. So that's going to be our function, x plus 1. Now, normally before, when we were revolving it around the x-axis, it would have just been the x-axis. It would have just been y equals 0. So it would have just been our curve, or x plus 1. Well, now it's that extra distance there, that 1. All right, so you have to be very explicit about the distance that you are measuring. All right, so there is our big radius, r equals x plus 2. And now we're just taking away that small radius. That's the distance between y equals -1 and the x-axis. So that's 1. All right, and now we're doing our big volume, take away our small volume. So our big volume is obviously going to be the outer radius there in the blue, or in the orange, excuse me. So that's the x plus 2. And the small one is the one in the blue, so that's 1, all right? Now we're just going to plug it into our formula. We're not going to solve this. We just want to really set this integral up. Be explicit about what you're measuring. So we're going to put the big radius there, x plus 2 squared. Take away the small radius, hence the washer method. And then now we're inserting our bounds. This is 0 and 1. Of course, we knew it was x bounds because we were revolving around a horizontal line. Of course, the x-axis is also horizontal. So this is our standard one. We're not doing this about the y-axis or anything like that, not yet, okay? Well, we can combine these now. We can FOIL that quadratic, the x plus 2 squared, and get x squared plus 4x plus 4, and of course we're taking away the 1, and we'll get plus 3. This is the integral that you can integrate, and I expect you to be able to do that if you understood this conversation. I hope this helps.